Very good morning to all of you students. Today we are going to learn the basic definitions of basic terminologies of Opencast mining related technologies. Well, my name is B. Karuna Kumar, HOD Mining, a Government Polytechnic, Kottagudem. Well, this is actually related to the different basic concepts of the surface mining. The duration of the slide shows are around 50 minutes. List the different open cost mining terminologies are a subtopic through PPTs and voice over video explanation. Uh, Upcoming around 33 slides providing in its guest lecture. So one by one we discussing about the uh, different basic terminologies. But a basic objective of this lecturer define the terms related to surface mining. Depth of the hole is one of the word. Spacing, burden, toy, crust, and vibrate. Earlier lessons, we are already aware that covered outcrops, overburden, face and bench and floor of the bench. In this lesson, we are going for these definition: depth of the hole and spacing, burden, toy, crust, and back break. What is the relation between the burden and the spacing, include depth, the how to calculations of these will be going to be discussed of the upcoming slides. Well, so this is a general view of the open cast benches. This is general view. Launching some more, extending some more, for a good visibility. Right. So here, the general the bench, the open cast is a formation is around the bench formation is a basic things in the open cast mining system. Here we see the different terminologies here given. One is the bear. It is the bear. This is a width of the bear here showing them. Here showing here. This is called as a back break. This is called as a back break. And the bench design angle. This is the bench design angle. This is another bar. It's a bench toy. This is called as a toy. This is a bench face. To attracting the face means in underground you can move in front, but the face is nothing but the what are the attacking of standing on the shovel here and attacking to the or we have to all deconcentrate by the drilling and blasting. So this is called as a face. From the top bench to the bottom bench top is called as a bench height. So these are the basic idea to whenever further classes going your depth. The simply what is the mean by bench face means is a face bench. This is a bench height. Is a bench. The top was crest. The top was the toys. Similarly, a toy is also there here given formation of the toys. This is the angle of design interpretation angle. Inter ramp height RH they call as RH. Ramp setup out. Design overall slope angle theta is given here. Pit crest is also given here. Now, Opencast earlier classes you also are well known that it is a outcrop deposit. It may be beneath the earth crust and below the few meters or sometimes kilometers or meters, depending upon the mineralization character and mineralization deposit. So now in the open cast, when option is taken, want to go through the open cast. Here we observe that if your outcrop is this much, so vertically it will be depth is more instead of extensible things. In such cases, our deposit is you extracted this mined ore. Not only that one, This portion is also you have to extract due to the safety point of the maintaining of the slope angle to traveling of the all the movements of the vehicles until you have take complete extraction of the ore body. Right here, you see that this is the actual extractable ore body, but you are starting here and to here. So this is the phenomenon. It is like a Bayesian shape. This is a Bayesian shape. So if 1 degree of angle is changed, the huge amount of wastage will have to extract. So the optimization of angle is very, very, very essential while designing of the open pit. Open. This is the general host rock. This is the ore body. This is the mine waste, former ground surfaces. This is the general ground surface. These are the stages to going inside to the widening of the. This is also simple technique. Is for example, this here to here and here to here. This much of the block you would extracted. This is a numerator, and over that one, this is OB. This area, this area. OB by this that is called as stripping ratio. The simple definition we can be able to explain. And then same that is also showing here in a different fashion. This is the PT depth. I am showing here. This is the PT depth. Top slope angle, overall slope angle. So this is the influencing factor. Here we see that here. So this is the same thing here I am showing here. So this is overall slope. If 1 degree increase or decrease from the verticality, from verticality to this part is also horizontal. If 1 degree increases, the benefit is otherwise, and otherwise when it decreases, the benefit is different. So the choosing of the overall slope angle is very important. So bit crest, bench face angle, each bench have the own angles. Inter ramp angles also there. Bench width is also here given. This is the bench height. So overall, this is the bench width. This is the height. So do we get the volume of the bench while explosive blasting and material disconsolidated calculation purpose? We require these parameters. And then what I was in early slide is showing that one. Here, graphical representation. This is the ore. This is our target is to extract this one. But this is the one pattern. This is one pattern. Another is this is the pattern. What happen if you change the slope angle? Here clearly understand. You see that if the slope angle is this much, your wastage is this much, you can be extracted. But if the slope angle is more, the wastage will value huge volume is increasing. Automatically, the OB removal, more OB removal is required. So, what just happened to the hour burden is volume? What just happened to stripping ratio? This is very, very clearly understandable pictorial conclusion. So here what I conclude that pit slope makes a big difference in open pits. So this is a dominating word. This is what is a very dominating word here. What is the concluding that simply do not go through the thumb rule, this much of angle you maintain, but according to the material characters and soil and property, slope stability can be maintained. For example, there will be dependent material to material activity. It's not fixing by 75 degrees. It's not fixed in the 90 degrees. So in such cases, the material slope stability is material character means the material angle of repose also one of the fun factor. According to that, what design engineers have designed the angle of the slope. So pit slope makes a big difference in open pits. That will here I showing here. Then next slides, I go to next slides. Right. So here you can observe you can easily uh, observe how to cut, cutting the uh, entry level. Here, this is called as a first cut. This is a top level. This is top level. This is surface. So this by seeing first step we have to start here to start at the ramp shape we have to extract it. The waste is exposed here and overburden is exposed here. That is you're seeing the above figure similarly. So this is the ore body. This is one. Those all are equal. But once you have to prepare the bench for coal bench, your preparation is also important. So such conditions, you go to the second figure is showing here. So first next step, and then further next step, and further next step. So during the processing, the OB bottommost OB, that is what you call ore bottom point reached. So our ore complete extraction is completed. At that time, the how much OB you are removed, this much divided by the that will be the stripping ratio of the particular uh, mine. So this is one pictorial explanation for the how the open cast view showing here. Next, this is a calculation procedure for the open origin put. Same, what are the showing early slides? Similarly, just like right. So this is the main basic type. What is the waste? How much waste is coming, and what is the work? That is in the same way in the calculation procedure. The how much volume of we extracting, that will be explained here in a simple example. Here we observe that one. There is a AO, A1, A2 are the uh, major thing, major uh, areas, locations. This is the A2, this is the A2, this is the A1, right? Similarly, there is a stages are there. Six stages, six benches are one, two, three, four. For example, this is showing the six. Each bench have it depth has overall depth is 90 meters is showing here. So 100 meters is the ore width is almost 100 meters here given. 200 meters is another block varying from the center to these sides. So here A0 is equal 200 into 60. 60 is the each bench have the 10 meters, so such a calculation is it, plus 30 into 150. So this is the A0. That means 16,500 meter cube of worth. That is 200 into this much 60 plus 30 into 150. So 16,500 meters of the volume of the ore will be extracted. So this is the mineral is concerned. Coming to the what is the waste? The waste AW is this side and this side. The both side will be waste will coming. So 100, there is a 100 meters. Yeah, this is the width means we can be simply say that the every ore body have the thickness as well as so this showing this side actually that 100 into 200 block. That's why he is showing here. So 100 into 60, so 60,000 meters square. So stripping rules how will coming 6,000 meter square by 6,000. So 0.36 is a good economical for the point of view the stripping ratio. So this is a simple typical problem. We can be practice some more this type of examples to calculate stripping whether this is a optimal mine or is there any problematic way. This is a design. While design itself, the not while operating thing because geological conditions based on the plan, the how much angle you have to go to maintain. Depending upon that one, we, before to go to the original pit, this type of calculation is essential for to know the our awareness how much waste, how much cubic meter of the waste coming, how much meter cube of volume, tons of the uh, core or mineral ore are coming to the particular mine. Then same is showing the very understandable without any numerical things. The simple the ore body you can understand the pit bottom. This is the pit top. So for which you have to this much of angle you have to maintain so that this is the waste and also this is also waste. So pit limit at the left side and pit limit for the right side. So these are also the influencing factors. So overall ore body extractable. and remain. The waste will be coming to the. So here, this is one typical understandable, easier understandable how to stripping ratio can be calculated here. This is the one typical example. And same figure I can show you here. So overall slope angle is a one influence factor. The above discussion is based on above discussion. This overall slope angle is not the ordinary thing. It is very, very, very important to while designing of the any open beta or open cast mine uh, to full profitable things to coming. The how much is this influencing is the above two examples. It will show the overall angle is very important factor. One more idea. Then coming to the each one, what is the depth of the hole? Depth of the hole, or usually in the soft strata, the blast hole length can be taken equal to the bench height. But in hard strata, it is a bench height plus subgrade. So overall bench height is automatically depth of the hole equally. But normal. But in case of to avoiding the toy formations or something, they go through the some grade. So overall bench height plus subgrade release is called as the depth of the hole. This is a standardized formula for the depth of the hole is concerned. Then here one of the pictorial view of the bench. The for drilling purpose, there number of holes are made with the driller down the hole drill or rotary or exploded maybe up to the bottommost bench floor. So this is actually, but due to the future coming next formation of bench, uh, without any over breaking or toy formation is there. Again, you have to removing the eyeball is very difficult. In such conditions, this is a subgrade you have to maintain. The how much subgrade you maintain is one of the big challenge. That is most of the 10%, 10% of the overall deal. For example, 10, example the 10 meters thing, another 1 meter will be taken as a subgrade. So overall 11 meters is the length of the hole. Similar other parameters is also there. I will coming slides can go through explain these things also. Another is spacing. It is the distance between the successive holes existing in a row. It is the distance between the successive holes existing in a row. It is a distance between the successive holes exist in a row. Long spacing create craters. Long spacing create crater. Crater is the word one you have to observe. The crater means the blasting phenomena is not happening properly. Automatically, crater means the explosive will blast in the top side, not instead of going to horizontal, the horizontal creativity of the shock waves. It will come outside. That is called crater. Whereas the short spacing cause over fragmentation. This is also a big challenge. The fly rocks is a fire problem is also there. So this type of uh, this type of spacing is one of the important factor for the uh, design of the blasting of the effective. There will be waste explosive energy and resulting is of white dust. So you can observe then if more successive holes, the problem is cratering. If the short holes, again there will be the fine dust and explosive energy will be lost. So unnecessary we are more utilizing the particular block or particular rock. So I am showing here what is the space and what is the button. Here there is a pattern, bench pattern in the top view. The hole is showing here. This is the hole, the blast. There is a stemming material we are using. This is the actual explosive column. There's red showing the actual explosive column. The primer is there, blasting agents. So these are the general column, the filling of the column here is showing. Coming to the here, the hole to hole, this is called spacing. And we here observe the first two row to the open space, that is a free face to call as a button. The remaining all times the button to this is a button, this is a button, this is button. The button each row hole to hole is called spacing. So spacing into button into depth, you will get the volume of the particular hole. How much volume it will get for a particular hole will be getting. So this is the called as spacing. And then yes, so spacing. Right here, similarly, another typical picture I is showing here. Um, spacing. This is the spacing, the hole to hole, and these are the buttons from free paste to the buttons. These are the buttons. The stemming, first called stemming column, the column charge hole depth, and also given is a subgrade drilling. This is the bottom charge. So this is the one typical example of the for a clear understandable for the what is the spacing and what is the button. Right. One more example I showing here. Already I earlier showing it. So here nomenclature is H equal to bench height, B is a button, S is a spacing, L is hole length, J is a subgrade drill or subdrill, T is a stemming, capital D is a hole diameter. Because D is also one of the important factor. If more dimension, more diameter of the hole, more explosive will be can be fit. So instead of depth, the increasing the hole diameter is also high explosive utilizing fragmentation size can be increased by the these factors. So hole diameter is also one of the important factor. So here if figure you can be easily understand the there is a toy is here. This is the button. This is a button. This charging crest is there. A hatch toy. Button is here. Spacing here is showing that. This is J subdrill is showing it. Stemming. I already mentioned him. This is the spacing. This is the spacing. And this hole is here. Hole is there. This hole is correct. D is the diameter. So overall, these are the basic terminology. Whenever whatever you are calculated, this terminology must be known to the before calculations or something. Now I am coming to the next slide. There is a button. What is the mean by button? Button means the minimum distance. Button means the minimum distance from the face. Button means the minimum distance from the face to the blast hole for the first row. It is a minimum distance from the center of the blast hole to the free face. It is a minimum distance from the center of the blast hole to the free face. Should not be greater than the bench height. So that is very important. If a button is more, you will not get nothing. It is just to shake the area only. So button should not be greater than the bench height. There is a very principal things. But the too short button cause excessive fragmentation, fly rock over material large distance. So optimum button is a very important. So once again I read again this slide. Button means the minimum distance from the face to the blast hole of the first row. It is the minimum distance from the center of the blast holes to the free face. It should be greater than the bench height. But the too short button causes excessive fragmentation and fly over the material a large distance. So button is also one of the important factor. Earlier we also learned the earlier slide is spacing between the spacing is more. So what happened? This will be problem of the cratering. If the spacing between less, more fragmentation is happened. Low explosive cost will be increased because We are utilizing more explosive for the simplified things. So these are the space and button is a very important factors, important items you can be observed here. Another is the button stemming spacing. Spacing is there here, and also button is a bench height. So bottom charge subtle. So here I repeatedly telling the spacing is distance between the two holes. Button is from face to the first row. It's called as a button. So the button should not be more than bench height. If the bench height is there, so button is more. So there is no use. Not really effective blasting is not happen. Right. I come to the next slide. So this slide is also more explainable rather than the earlier slides. Very clearly here I mentioned here. This is the stemming column, the whole depth. This is the explosive column, sub drill, grade floor. This is the bench height, free face. These are the button. These are the drill holes. So hole diameter. So for all these are the very big for bench. These parameters are the major things. Now we coming to the parameters, blasting parameters. See here, the powder factor is major influence factor. What is the mean by power factor? Power factor means powder factor is the amount of explosive in kg required to achieve a 1 ton of the mineral. So you utilizing the explosive for a defragmentation of the mineral or rock or any, I mean, it may be ore button is also moving. So whatever it may be, the powder factor is the explosive gauge required to yield how much yield you will get, whether it metal or OB. I will here simple I mentioned here. Here as I mentioned on mineral, it not be it not be mineral. It may be OB also. So what are the one kg of explosive or 1 ton of mineral will get? So amount of rock per hole. So volume is equal to B is button, S is the spacing, H is the height of the bench, nothing but is the depth of the hole. Okay, amount of rock per hole, V equal to volume is equal to button, spacing, and height. So button is equal to spacing height. The volume of the rock can be calculated by this. So you can be observed here is also how value we will be getting. So button is there, spacing is there, so depth is there. So here we will get the overall volume of the uh, for explosive 1 kg of explosive, how much volume will be getting the called as a powder factor. Now the other terminology is the before I go to the other terminologies, there is a stemming important, explosive column important, and sub drill important. And before I go to the other two, there's the toy, back break, and crust. Another three definitions are also there. Here we are observing uh, here you observe the spacing and face button. So face button. So we'll get a volume of here. So this is a crust. So explosive column, if the character of this what do you call geological conditions, particular this block have any weak strata. So why unnecessary explosive filling? Some they are using control blasting. That is called as a control blasting for which explosive major influence, not only explosive. The spacing and button and depth is also one of the important factors of that point of view. right? Now I go to the toy. So what is the mean by toy? What is the mean by the toy? It is a projection of slope. It is a projection of slope behind the crest. It is a projection of the slope behind the crest. Sometimes the unbroken rock at the floor can be treated as a toy. Sometimes the unbroken rock at the floor can be treated as a toy. Toy is a projection of the bottom of the face behind the crest. Toy is a projection. Toy is a projection of the bottom of the face behind the crest. So these two, this is toy is the whether it is required or not. First definitions you can understand. Toy is a unwanted thing because the area will be zigzagging nature. I can show the with the figure here. Well, well, so toy is the this is the bench. Let's show you here one more thing. I can show here itself only, no problem. So here you can explain well here. Good slide, yes. It's also not. Yes, here if the subgrade is not there, subgrade is not happen. So from here to here, explosive column is there. Here to here, explosive column is there. If explosive stemming is not properly maintained or something, what happened? The entire influence will be in around this area. So what's in such conditions? Here, the next bench formation top crest is not a maintained a uniform. It will be some zigzag and some meter will be here. So our aim to cut exactly here. So such will not happen. So that way our depth of the hole, the addition 10%, that is another 10% and that is 1 meter. For 10 meters with 11 1 meter, another 1 meter will be. There will be 6 meters, zero point 0.6. So that if any explosive creativity, the exactly the uniformity happening, the toy formation to avoid this happen. So that's I would like to explain that here. So next toy is one factor. There is the projection of the slope. It's a projection. It is a projection of the slope behind the crest. So you have where the crest should be this much, but crest is for example you have to maintain the 10 meters, but over the crest the material the another 0.2 meters or 0.6 meters will happen. So that should not happen. Otherwise again you have to by with your hand jackhammer or something the maintenance is the tedious work. It is a very tedious work. So that's why the toy formation must be avoided. The toy marble must be avoided. Sometimes the unbroken rock at the floor can be treated as a toy. So toy is projection model. So this is about that. And then coming to the next crust. The crust is a different opposite of the toy. Crust is a top. It is a line joining highest elevated points running along the marginal plane of the end of the floor. It is a line joining highest elevated point running along the margin plane at the end of the floor with the bank. So this is the crust. The crust is also the bottom of the toy is there. Crust is the topmost. Crust is the topmost one. Then what is the mean by back break? So this is also one influence important. What is the mean by back break? It is a fracture of plane. It is a fracture plane. It is a fracture plane formed is a fracture plane formed behind the blast hole from the free face. This is also very important. Otherwise, our target is one line is there. So due to the explosive charge, this one will be happening back break. So you should be see the no toy formation. Crust should be maintained proper. Back break is also made behind the last hole from the free phase. Also the very important. So that can be showing here again. So for example, this is all. This is the back break. So this is you should be uniform. This should be uniform. That is called as a back break. In other sense, it is the line joining of fragments taken from the individual individual creators. That means from the fragmentation taken, each ore have its own creators property, creator things. So these are the uh, things we are overall completing the this lecture. I think you can understandable. So again, we are summarizing the what are your learned, what are the covered in this class. What there is the depth of the hole. That is a one thing. Depth of the hole is one of the factor. That is already understand depth of the hole is depending upon the um, uh, depth, depth of the hole is depending upon the um depending upon the excavators how much you guys that is a inflation, and spacing is also distance between what you call hole to hole. The button is from free phase to that one toy. They should not be forming to maintain the subgrade sub drill, and then crust is also one of the factor, and back break have to maintain the important things. So these are the very explainable in one figure. We could easily understand all these definitions, basic definitions. Hole diameter is also one of the important parameter. If a number of holes is less, the hole diameter automatically large. In 300 diameter to 33 uh, holes also you are using in the open cast mine system. So this is very essential parameter for heavy drills they are using for the making of the holes. So drill holes is these are the burden is the first free phase to first row is called burden, and this is the free phase, so that this is called as a burden. So burden should not be more than the height of the bench to maintain the burden optimum. Optimum you have to maintain the burden is very essential. And similarly, the spacing is a hole to hole. The distance between the hole to hole is called as the spacing. These also one important. More spacing will be a disadvantage. Unnecessary crater is forming. They are not good fragment is not be expecting. So similarly, depth of the hole and depth of hole without crust, what you call toy formation. To avoid the toy formation, maintain the sub drill. Sub drill is 10% of the major drill. That much you have to before idea. You have to drill that one. The explosive column is filled from the bottom to 3 by 4th of the column by explosive which is suitable for particular location, and remain stemming is proper stemming. So these are the whole crust is another point, and back breaking should be maintained. Back breaking line is important. So these are the terminologies. These are the major terminologies you are observed here. Coming to uh, the summaries. So overall, our major items are covered. I am going to the quiz. Quiz is one of the important parameter for the competitive examinations. For example, you go at in the ESET, somebody will write the JMET examinations. That is a competitive exam in the coal mines, particularly the Singareni or MG Coal India or Western Coalfield, Naval India, wherever. So the patterns they are asking in the related questions. So one question I model I is showing here. Usually, usually in the soft strata, usually in the soft strata, the the blast hole length can be taken usually the soft strata, the blast hole length can be taken equal to the bench height, equal to the bench height. More the bench height, less the bench height, none of the above. So answer is yeah, equal to the bench height. Usually, softer blast hole length can be taken each, but here critical analysis there. But why we were taking subdrill? Subdrill you are taking whenever the strata is in hard in nature. So if the why you are taking less than bench height, what happened? The automatic toy formation is happened. So overall, if is one question have 3 to 4 answers you can expect it here. Okay, 3 to 4 answers you can be expected. So that means the soft rock you go to the equal to the bench height. For hard rock you go the more to the bench height. So if less the bench height, the toy formation happen. So the present as is a statement is concerned, usually the soft strata, the blast hole length can be taken is a first answer is the answer one. So now we more some you can practice in our homework as a write the assignment on back break. What is it is important, why it is maintaining is a one of the important parameter. This is taking the assignment. This taking the assignment for the purpose of preparation of work. Uh, right. So now it concluding the this slideshow. So thank you on all of you. This is a chapter completely basic. I hope that you can understand a basic idea, basic terminologies which are using in the opencast mind. Particularly, these terminologies are helpful to the while calculations of all the things. Once I want to showing all the slides once again to understand the uh, for understanding, and you can be easily note the notes for the for purpose. Now I showing the slides one by one. Please go through it. Right. So these are the slides. So I was what I was explained. So I hope you can understand the all the basic things related to open custody terminologies from the earlier class and this class. I wish you all the best in your success. Thank you. Thank you very much.